So much to say, but I can't. Try again.
As documented in this video, the performances which required live sound reinforcement consist of the recitals of Perth College music performance students. Each engineer was allocated multiple recitals to organise and oversee, and this included both front of house mixing and monitor desk operations. As it is useful to work with a partner when working in live sound reinforcement, engineers were organised into pairs, with one taking on the role of front of house and the other performing monitor mixing duties. Roles were shared equally to ensure that all engineers performed all tasks. Other tasks included pre-production liaisons with performers, system setup, fault finding and fixing, and the implementation of safe working procedures. Meeting with artists to organise how their set will be engineered ahead of time yields many benefits. Details of band members, set list, date and duration of performance, and any extra requirements such as accompanying video can be brought to light in one simple meeting ahead of time. Scenes are an advanced way to take a set from being engineered in a basic manner to being engineered in a professional manner. By employing the use of scenes, changes in the show's configurations can be handled ahead of time, and so the progression of the show becomes as seamless as possible.
A quick overview. We've got our direct outs here going to the Dante network. I'll explain that in a minute. If we go to our I/O section, we can see the DL251. All the inputs are enabled, and they are going to our input section on the MIDAS control surface here. The controller for the amps is connected via this bodged cable here, and it's converted to Cat5 cable. That goes right round the theatre and all the way down here, and that's going to both the controllers for doing all our crossover functions. Here we have the amp for the delay speakers. If I turn that on and give it volume, it's powering these two speakers in the overhead passage here. These are obviously delayed from the line array, which is in turn delayed from the back line. But this can be done in a number of ways. To do it on the desk is perfectly acceptable. However, it's saved in scene information, so if a different scene's loaded up and another person wants to use the speakers up here, they're going to have to recalibrate their delays. So what we do is we run the feed from this, from the amp that's controlled by the crossover for those Cyclops speakers down there. So using that method, we can go for a delay that's going to be on all the time. We've got a Clark Technic DN9650 converting our AES signal from the MIDAS into Dante, which is opening up a Dante network to which we've got systems and computers connected. This is Reaper, which is taking the audio from the direct outs of the MIDAS. In this particular computer, I've got a Dante network virtual sound card. I can see all the audio over here, and I can even run effects from here back to the AES 50, 4, 5 and 6. The first three AES ports on the back of the MIDAS Pro come into the DL251 here. We've got two channels for two lines for the audio to go down, and then we've got a redundant line should anything happen to either one of these. But to make it all work, we've got the Dante controller. Open up the receiver, you'd see, and then my computer here, Rio, you'd see that we've linked all the individual channels. So I'm tapped into the audio that's coming from the direct outs. If I click my effects button here, it takes me to, well, I've got two options. I can click it twice and I've got my equalization and I've got my effects. So basically I've got 1, 2, 3, 4, 5, 6 units. So I've gone for a reverb for my drums, a reverb for my vocals, a vocal delay, and then I've got two stereo compressors which I'm running vocals through. This is send 1, send 2, send 3,
and I've got them going to my effects unit. So the way you look at your effects unit is 1, 2, 3, 4, 5, 6. This was my 6 slots of effects. I'll show you if I click that. They'll both light up. So what I have to do then is come out of my effects unit the same way, and I can put them into regular channel strips, giving me dynamic control, because the dynamic controls work over the strips, but they don't work over the aux returns. But I don't need them, so I could leave those channels open and use my aux returns here, and aux return ambient left, ambient right, Vox 1, Vox left, Vox right, and my delay. And my sends are all up. Now my lovely compressors are a bit more sophisticated than the basic one. I can send certain things through these and further compress them with much more controls. And to do that, the patching is slightly different. What I would have to do is go to my insert sends. Over here I've got vocal centers. So Alison right now is going to be compressed. I send her to the effects unit, or delay effects, and that's going to the left input, source 1 and then source 2 obviously. And if I come over here, I've got the effects unit, and I come out of the same one and into my insert returns, and now I've got my vocal return. If I come over and select a channel that has not had an insert routed through the patch bay, the virtual patch bay, and I come over here and I click insert, nothing happens. However, if I go to one of my Vox center, which I have routed, the insert becomes available, and you'll see it there. Now I've got Matrix 1 is the left hand speaker going up to the left, and then on the right side we've got Matrix 2 going up to the right, so that the delay speakers get the same feed as the line array it's in front of, and then they're both being sent to the subs via Matrix 3. So that means that anything we put through left and right is automatically going to go to all our sources. For controls for my Matrix outputs here, obviously this is the balcony speakers. I'll show you them in action in a minute. And then I've got my Matrix for my sub. Now I had a little bit of fun with taking the sub and boosting the bass on it. Playback is up. Take the master down. Unmute those. Let's get some music going. Bit of Bowie. Wake up sleepyhead.
Shake out your bed. Put another love on the fire. What are we coming to? No room for me, no fun.
There's the subs there.
I'll think about a world
No
to
subs.
come, where the books were found by the golden ones.
I'll just show you the balconies coming in and out.
Oh, you breathe.
Linked up the radio mics to the monitors. Let's get a good song on for the bass here.
White, black and white.
Oh, it just says battery. It doesn't record in black and white. If I go, maybe let's get some Exodus. I am Abomination.
You're an abomination.
I'm going to walk through how I've got the desk set up as ergonomic as possible to make sound engineering fast and efficient. I've got pop groups up here, and I use that for my effects. I use my VCAs for individual batches of instruments. Not only can I name my VCAs, but when I've assigned them by holding in the button and selecting my channels that I want to be in the VCA, I can just choose a colour and then paint the rest of that colour. So when I'm in my overview, everything corresponds to the... When I engineered my gigs, I was well within the SPL limits, just because of the nature of the size of the audience. However, should sound pressure level have reached say 95 decibels, I would have had to leave after 4 hours.
This little Toshiba is also running Smart Live.
Smart Live is pretty much the industry standard for spectral analysis regarding live sound reinforcement. With the aid of Smart Live, there are techniques which can be employed to ensure that the audible spectrum of frequencies is appropriately balanced and are as close to the output equalization of the mixing desk as is possible. Smart Live is also used to align different sound sources to keep audio signals in phase as they are dispersed over the audience area. Obviously, all signals must be based off the backline, as this is the initial sound source, and the following technique describes how to quickly and efficiently distinguish the correct delays for any additional sound sources that continue on the axis of projection from this initial datum point.
So we're just setting up radio mics, and we've just patched them.
Wait.
They're coming into the back of the surface here on these 1, 2, 3.
All basically patched in? Or-
Yes, they are. And then I've got them coming.
Okay, so this is you taking recordings. So
Radio 1, 2, and 3.
coloured ones are the
We're
black
just
ones.
going to line check them
You could probably be better
and
with
set
that
the
one,
gains.
because
Using a correctly calibrated reference microphone positioned to begin with in the engineer's listening position, a track in Smart Live can show a digital representation of the frequency spectrum as it leaves the output speakers. This track can be visually compared against the desk's output equalization shape, and necessary adjustments can be made. Distinguishable by separate colour, the difference between the two inputs should become less and less until at a minimum. Pink noise is the type of audio signal best suited for this application, as all frequencies are played equally, meaning that each octave has the same amplitude or noise energy. All decent modern desks have the ability to output pink noise. The X32 is taking raw tracks that are free from processing, and they're sending out to various monitors. We've got a double set for the middle vocal, and we've got double sets for the stage right and stage left as well. We've also got a wedge for the drummer, a wedge for the pianist, and we've got side fills either side of the stage. The feed for each monitor comes out of the physical outputs on the back of the X32. The output buses can then be appropriately named based on what speaker they're supplying the signal to, and by clicking sends on faders, the faders on the left hand side of the board are now controlling how much of each signal is going to which monitor, and if one was to still have sends on faders but come over to the right hand side of the board and click a channel, it will quickly show what's going to that bus at any one particular time. As you can see, equalization and other processing can be applied to any of the channels or buses. Both the front of house and monitor desks have got multiple EQ functions. The front of house can be EQ'd to get the best sound in the room, however on the monitor desk the EQ is often used to try and combat feedback. By looking at the screen and watching where the spikes are and getting the performers to put their mouths right up to the microphone, or maybe even cup it slightly just to find out what the problem frequencies are going to be, then you can work to target those frequencies in the 32 band EQs, which you can apply over any of the outputs and just get rid of any of the 550 Hz hum, 2 kHz horrible sound in the vocal. You can just subtract it, get it right out of there, and it'll sound good to the people on stage, but it won't have any of the negative effects. There are many kinds of problems that often arise which an engineer must face. There are ways to conceptualize the signal path which will help. A very common problem is a break in the audio path that is preventing it from reaching the speakers. To locate this, one should check the meters at every single stage in chronological order. Is there audio on the input meter? If no, check phantom power, cabling and connections. Is the audio routed correctly? In the case of the MIDAS Pro series of consoles, checking the patching screen to make sure the correct connections have been made will fix this problem. Look for mutes on channels and pop groups and VCAs. Is there activity on the desk's output, or is the problem between the desk and the amp rack? Another problem which arose during this gig was an accidental fader flip, which resulted in all the mixing faders simply controlling the amount of reverb applied to each channel. A more experienced engineer had to be consulted, and although in a real-life scenario this would not be a viable option, it could have been helped by a desk manual to hand. If one's experience with a particular desk or piece of equipment is not extensive, then this would be advisory. Luckily, the festival was for students, and the most important thing here was to exploit the opportunity to learn from these kind of mistakes with reduced repercussions. If a thorough sound check or a rehearsal is not possible for any particular reason, one will have to create a desk template which can accommodate the majority of band lineups that are likely to occur. Overall, the gigs went well, and the performing students were full of thanks and compliments, and it was a good learning experience.